Hello my dear students, myself Ashish Diwan. I will teach you physics, two-dimensional projectile motion. First we know difference between one-dimensional and two-dimensional. Here is some example of one-dimensional motion. When we throw a body vertically upward from ground or from some height, vertically upward, vertically downward or drop. These are example of one-dimensional motion under gravity. A question arises in our mind, sir, if we throw a body horizontally from some height, is it example of one-dimensional motion? No, my dear students, no. It is example of two-dimensional. We can understand it by following diagram. Here height from ground and we throw a body with initial velocity u horizontally. Gravity acceleration is acting vertically downward. So the resultant is this and the path is this. It is not one dimensional, it is two dimensional motion. So it is example of two dimensional. What is projectile motion? When we throw a body at some angle from ground or from some height, in such a manner, its motion is always along parabolic path. These type of motion known as two-dimensional projectile motion. Yes, we can understand it by following diagram. It is y-axis, this one is x-axis. Now we throw a body with initial velocity u by making angle theta with horizontal from ground. This point is known as POP, not plaster of Paris, point of projection. Now it is vector quantity. So what we should have to do? Yes, split into two rectangular component system. This one is horizontal component of initial velocity u cos theta. This one is vertical component of initial velocity u sin theta, and the path would be parabolic. It will discuss further in equation of trajectory. Yes, this point is known as topmost point or highest point. At this point, velocity is minimum. So upgrade your software. Velocity is minimum but not equal to zero as in one-dimensional projectile motion. Here vertical component of velocity is zero, but throughout the motion horizontal component of velocity remain constant, that is u cos theta, because ax in horizontal direction acceleration 0 because force is 0. So throughout the motion velocity along horizontal direction remain constant and u cos theta. This point is known as point of impact. Yes, this one is top and this one is point. This maximum horizontal displacement is known as range. Yes, my dear student, it is known as range. It is maximum height. At maximum height, you can see there is, yes, velocity and gravity acceleration is acting vertically downward. Yes, this. So the angle between both is 90 degree. Here is the only point in two-dimensional projectile motion where velocity and acceleration both are mutually perpendicular to, yes, mutually perpendicular to each other. Remember it, it is very important point. If we see here at point P, direction of, yes, projectile is this, gravity acceleration is that, this angle is greater than 90, but this angle is equal to 90 degree. If we see the time, we know time of flight. It is time between point of point of projection and point of impact. This time is known as time of flight, or it is total time projectile into air. The time of flight, and this one is maximum height. Now we can see maximum range is a different thing and maximum horizontal displacement is different thing. Now we can move further to find equation of trajectory, because we are seeing here that there are two dimensions. One motion is along x and another motion is along y. So we should have to discuss in separate dimensions, x and y direction. As we know, acceleration in horizontal direction is 0, but there is gravity acceleration throughout the motion which acting, and it is constant. So we can apply which? Newton's equation. Yes, it is conditioned to apply Newton equation that acceleration should be